So hi everyone. Today we're going to work on our new form. It's called point slope form. Point slope form. Now, to review quickly about what we did before, we had other forms. We had standard form, and this was ax plus by equals to c. And one good thing about this form is that you could find the x-intercept and y-intercept as simple as one step. If I say 3x plus 4y equals to 12, the x-intercept, right, int here, x-intercept was just cover the y. 3 times what is 12, folks? 3 times what is 12? 3 times 4. That is our x-intercept. Solve for y-intercept. Cover up the x. 4 times what is 12? 12 divided by 4 is 3. And we could graph this 1, 2, 3, 4 in the x direction, 1, 2, 3 in the y direction, and that's our line. Okay, if you blink, you missed it. That's how easy it is. But we have to be able to identify that this is standard form and we can plug in the zeros quickly. That's a big takeaway. Our next form was what we call slope-intercept form. Slope-intercept form was y equals to mx plus b. Y equals to mx plus b, where m was my slope and b was my y-intercept. Sorry, I ran out of space. Intercept. Well, if I wrote the form y is equal to 2 over 3x plus 1, the amazing thing about this form is there's no work. Over here, we actually had to cross out one of the sides. But for this one, girls, I'm not trying to be sexist here, but girls, when you see a cute guy, you can tell he's cute, right? Automatically. See, I like his eyes, I like his nose, I like his hair, I like his clothes. That's what we're doing here. We're identifying the cute parts of this. The slope is 2 over 3, and the b is 1. So each of these parts help us graph this graph in just counting. The y-intercept, this is my y direction, that's a positive 1. Do not get it mixed up. It is not here. That's our x-intercept. And people mess up and always draw a dot there. No, y-intercept. That means it has to hit the y. The next part, oh. Sorry, darn it. You guys are, oops. That's a lot of comments on my cute part. All right, sorry. And then from the y-intercept, our slope is 2 over 3. But you have to know what slope means. Slope means rise over run. We always say rise over run. That's how we always will say slope till the end of the age. If you say run over rise, you're crazy. You're crazy. It's always rise over run. Think about right now, you guys are all seated. I want you guys to get up and go across the room. Are you gonna run first or are you gonna rise? You gotta get out of that chair. We're gonna rise by 1, 2. Then we're gonna run by 1, 2, 3. Take a look, that's a positive 3 and a positive 2. That's my rise and my run, put a dot. That's my directions. That's Google Maps for me to get to my next point. So we're identifying the cute parts, right? This guy has a cute nose, he has a cute wallet. It's a pretty fat wallet. Nice credit cards. Sorry, shouldn't say that. So our line here, if we're given slope-intercept form, we know how to graph it already. We see that it's changing by 2 over 3, and we start at 1. This is my starting value, and this is my change, Obama. Okay, start and change, which is great. And we worked before, we said if something isn't slope-intercept form, we want to try to solve for y. We're going to change it. And we were able to change problems that were not in slope-intercept form. If I said, let's do it one more time. Sorry, I'm running out of space here. But if I say negative 2x plus 3 equals 3y equals to 3. So on our last lesson, we were able to change this to solve for y. Solve for this here. So we got rid of the 2x plus 2x. This is what you guys did in IXL. 2x plus 3. And then we divided everyone by 3. Divide by 3, divide by 3, divide by 3. Y is equal to 2 over 3x plus 1, which is how we ended up with this guy here. So today we have a new form, and this form is just as easy, I'm telling you right now, just as easy as point slope form. It might look bigger, it might look a little more messy, but it's really not hard. It's actually easier, I would say. So our point slope form, let's go back to the top, is y minus, who thinks y is going to minus by? Y is going to minus y. Y1 is equal to m parentheses x minus x1. Now this is what we call point slope form. We will always treat this as point slope form. Y minus y1 equals to m. If you need a flashcard to memorize this, do it. You gotta write this 5 times, do it. But our 3 different forms are super important because they have 3 different characteristics. You guys ever pick up the wrong car key and try to stick it into a car and it doesn't turn? Wrong characteristics, not gonna work. You pick up the wrong house key, try to force it in, not gonna unlock anything because different characteristics. And we wanna make sure you pick the right key for this right door. And this door here is point slope form. Now, if you guys are kind of quick on the pickup, you might have noticed that x and y, that's my point. And the m is my slope. We call this point slope form because you are given a point and a slope in this formula. It's like showing there. It's like me opening up my wallet. Everyone can see how much money I have. There's nothing in there. Y minus 3 is equal to 1/2 x plus 1. Now, the decoding part, right, is the hard part. We want to make sure we first understand the parts. Now we can decode it. If anyone has ever studied how to read computer bytes or hacking, you need to understand what information is coming in before you can try to decode it. Right? Is this a header file? Is this a picture? Is this a document file? Your computer has .exe, .doc, JPG. These are the coding so that the software, when it sees it, knows how to read the file. So we know point slope form, we want to be able to read this file. So m is 1/2. This is my x and my y. Now we have everything we need. The point is -1, 3. Why is it -1, Mr. Ko? Because like our other examples, the negatives are already there. So this is really x minus a -1. So that's a big mistake that kids always forget, that the negative is already there. So I need another negative to make it positive. How about the 3? Well, y minus 3. Well, the 3 is fine. The negative is already there. See, the negative is already there. And the slope is 1/2. Now, why would I say this is easier than y-intercept? Because I gave you the point. Let's go find that point. -1, 1, 2, 3. Put a dot. And the rise over the run. Rise over here. Rise over run is 1, run 2. There we go. Let's look at this graph and work backwards. Does this graph have the characteristics that we were trying to plot? Okay. I'm just putting some lines there so you can see these are lines. Okay. That was a little off, sorry. Darn it. I don't have time for this. Okay. So if I want to go backwards, please look at this graph here and tell me what is an easy point you know. And you could just literally recite what we just wrote down. But this is -1 and 3. So would you guys be okay with this point right here? -1, 3? So my point is -1, 3. What is the slope? How to get from one easy point to another easy point? We rise by 1 and we run by 2. M is equal to 1 over 2. That's it. Yeah, that's it. Let's go backwards. Let me give you guys a point. The point is 1, 2. 1, comma 2. I'm going to go to a point up here. 1, 2. Now, your IXL is going to give you a regular graph, and you have to write the equation from that graph. But we have to look for easy points. Now, easy point here is 1, comma 2. So my point is 1, comma 2. And what's my slope? My slope is rise 1, 2, run 1. 2 over 1. Now we have everything to fill out our point slope form. Y minus y1 equals to m, x minus x1. So do we have an x1 and y1 here? Nope, that's a x, that's not the y. Here's our y value, and here is our x value. Y minus 2 equals to blank x minus 1. That's my x and y. And the slope, so what's the m value? 2 over 1, or just 2. Now, that's the basic idea, honestly. If I give you guys this, what if I write m is 5 and our point is 10, no, that's 10, let's use 2, comma 3. Write the equation in slope-intercept form. So if you look at what's given and what they want, are they the same thing? Slope-intercept versus point-slope. Now, another task, and this is the critical thinking part, is that, hey, they want slope-intercept, but I don't have intercept, I have the slope. So we're going to use our point-slope form. Y minus y1 is equal to m x minus x1, which is going to be 2 here. And what we're going to do, we're going to multiply this out and transform it to slope-intercept form. We'll transform it to y equals mx plus b. We're going to transform it. How do you transform it? This is straight week 1, algebra 1. We're going to get rid of the parentheses. Everyone, look, I'm going to multiply out the parentheses. Y minus 3 equals to 5x minus 10. I multiply out the parentheses. Next move, solve for y. I need y to be alone. Excuse me, 3, can you move to the other side? Yes, yes. Y equals to 5x minus 7. And we are now in slope-intercept form. What if this was a fraction problem? That's okay. I'm going to give you not a graph, just information. My slope is 1 over 2, and my point is 4, comma, -1. So we just fill in what we know. Y minus -1 equals to the slope, x minus x, which is 4. Again, we get rid of the parentheses by multiplying out the fraction, in this case. Y plus 1 is equal to 1/2 x. What's half of 4? Half of 4 is 2. 4 times 1/2 equals to 4 over 2, which reduces to 2. Don't forget there's a negative there, okay? One last step. Solve for y. Y is equal to 1/2 x minus 3. Look at all the work I have to show. But none of this stuff is, darn it. Oh, there's a lag. Sorry, there's a lag right now. Okay. So our issue is to write a point slope form into slope-intercept form. That's one type of problem. The hardest problem here is this next step. What if I give you 2 points? Okay. If I give you 5, 2, let's do 5, 2. And 7, let's do 3. Do we have a formula that just has 2 points? We have slope, intercept. We have point, slope. And yes, there is a 2-point form. And if you look it up on Google in your book, there is a 2-point form. But we're not going to do that. We're going to instead slightly cheat this problem. We're going to say, hey, if you have 2 points, how do I find the slope of 2 points? If you remember, the slope equation is y2 minus y1 over x2 minus x1. And that's our m value. And that's what we're going to use first. Once we have a slope, we have the equation. We're done. Let's find the slope. 3 minus 2 over 7 minus 5 is 1 over 2. We have our slope. Oh my gosh, I think that took me almost 5 seconds. Now, if we have a slope, you can pick any one of these points, whichever one you think is easier. I think 5, 2 is easier. So we have a point and a slope. Our point, 5, 2, and our slope is 1/2. Let's go ahead and fill out the equation. Point slope form. Point y minus 2 is equal to 1 over 2, x minus 5. The goal is that we identify what we have, what our tools are, and then how to use these tools to answer the question that they're asking. So if they want us to stop here at point slope form, we are 100% done. If they want us to transfer this to slope-intercept form, fine. There's going to be a fraction in this problem. Y minus 2 is equal to 1/2 x. 5 times 1/2 is 5 over 2. Leave it as a fraction. Don't be afraid of it. Next move, I'm going to add 2 to both sides. Hey, 5 over 2 does not add to a fraction. Rusko, I hate fractions. I hate complaining. You still have to do it. You're going to still complain. So my fraction is a 2. I'm going to give myself a 2 over 2. That becomes 4 over 2. Isn't 4 over 2 the same as 2 over 2? Hopefully you agree. We're going to combine our 5 over 2 and our 4 over 2. We went and made change. Y is equal to 1/2 x. 5, negative 5, plus 4 is a negative 1 over 2. And that is our equation in slope-intercept form. Okay. That in a bundle is homework number 20. And if you need more examples, you can watch the video that's already posted there. So there'll be 2 videos posted for homework number 20. Okay, let's look at the next chapter. This was supposed to be today's lesson. And today's lesson is going to be working on perpendicular, perpendicular and parallel lines. Now, what's the difference between the two? For a perpendicular line, is that when 2 lines cross, they form a cross. Like they form a nice cross, like no joke. Boop. They form a 90-degree cross. And we show that as a little right angle, a little box in the corner. And parallel lines, parallel lines are lines that never touch. They never touch. So we're going to go ahead and do parallel lines first because that's actually easier. So how do you know lines are parallel? Parallel lines are parallel because they grow the same way. Have you ever seen twins, right? And they are always the same height. They're growing the same way. Have you ever seen lanes on the road? Are they changing the same way? They're parallel. So things that are parallel, they grow and they change the same way. For us in algebra, we have a word for change, and that's slope. The rise and the run, the rise and the run is exactly the same. So the way we know lines are parallel if they have the same slope. If they have the same slope, those lines are parallel. So if we'll call this line A and line B, the slope of A must equal to the slope of B. Oh, darn it, that's a little b. So slope was A, we said was rise 2, run 3. And the slope was B was rise 2, run 3. Are these lines parallel? Yeah, because they have to have the same slope. That's the only definition we're sticking to in algebra. If you hear something's parallel, you must have the same slope. You're changing the same way. I don't care about where you start off in life. I care about that you're changing the same way. You're growing the same way. So let's look at an example. Y equals to 2 over 3x plus 4, and y equals to 2 over 3x minus 1. Are these graphs exactly the same? Do they have the same slope though? And because the slopes are the same, we say yes. And we have a little sign here for parallel, yes, and it's a double vertical line. This symbol here means parallel. So if you see this symbol, it means parallel. These lines are parallel. What about perpendicular lines? Perpendicular lines, or let's say lines are perpendicular, lines are perpendicular when, so if we have M is A over B, okay? Just pick any number, A over B. We have a special formula to give you a perpendicular slope. The M perpendicular, look, perpendicular means it's an upside down T, this symbol, perpendicular, upside down T, it's an upside down T, T, it's negative B over A. Why is it negative? If one guy is going up, the other one must be going down. That's what perpendicular is. They have to be opposites from each other in almost every way. Not only is our rise and our run flipped, but also our signs are flipped. You go up, I go down. So we have to flip the slopes and the sign. So let's give you guys an example of this. If M equals to 1 over 2, that means the perpendicular slope must be, let's see if you guys can guess what it is. How do I give myself a flip? You flip the sign and you flip the fraction. That's all we do, flip the sign and we flip the fraction. If we flip the fraction, it's 2 over 1. And if we go from positive, we become negative. Positive becomes negative. So that's one example. Let's give you guys another example. If m is equal to 5 over 3, the perpendicular slope is just 3 over 5, but don't forget the negative sign. So we do a negative reciprocal. That's how we tell things are perpendicular to each other. We check the slope. If the slope is exactly the same, you don't have perpendicular lines, you have parallel lines. Why does everything start off with a P? Gosh. If they're exactly the same, you're growing the same way. Come on, we're in sync here. If they're perpendicular, they're against each other in every way. You say 1, I say, sorry, if you say 1/2, I say 2 over 1. If you say 5 over 3, I say 3 over 5. If you say positive, I say negative. We're at odds here. We're going to cross. So let me give you two equations. Y is equal to, let's do 4 over 7, x plus 2. And y is equal to negative 7 over 4, x plus 2. So be careful. I wrote some numbers that are exactly the same, and also some numbers are different. Now, for things that are perpendicular, the m value, that's going to write them out. That's my slope. That's all we care about. We don't care about where they start at. We care about how they change. So if we want something to be perpendicular, let's check. Is this a negative reciprocal? If I stick a negative, positive became negative, and 7 goes on top and 4 is on the bottom, yep, we are good. This is perpendicular. It's as simple as that. It looks a little silly, but that's what we're looking for.
But also you can just look at it because like that represents the slope. So if just the number is different, then just like
it has to be different, but it has to be a flip and the negative sign.
Oh, okay.
So both of those have to be true. Let's do it one more time. Y equals to, let's see, negative 4 over 8. No, let's not do 4 over 8. 4 over 5, x plus 2, and y is equal to 5 over 4, x minus 2. So look at the slopes. Did I flip the slopes correctly? And did I change the signs? So we flip it, becomes 5 over 4, and make it into a positive. Is that what we have over here?
Yeah.
Yeah. So that's one way. So these are not parallel, they're perpendicular. They're totally at odds. Now, here's a tricky question. If I give you a point, here's my points, 2, 3, and 5, let's do 5, 6, okay? Find the perpendicular, no, what? That's not even right, perpendicular. Let's just draw the symbol, perpendicular slope. If I give you 2 points, well, how do I find the slope of those 2 points? Well, we have an equation. M is equal to y2 minus y1 over x2 minus x1. We have an equation for that. So we're going to say 6 minus 3 over 5 minus 2. It's always pick one and subtract the other guy. You always have to go one way. It doesn't matter which way you go as long as you pick one side first. 6 minus 3, 5 minus 2. This is 3 over 3. Did I do that? Darn it. Freaking idiot. False. So I'm talking about me, not you guys. Oh, darn, this is being recorded. Okay, so my perpendicular slope would be, it still would be 3 over 3. But don't worry about the negative sign. Let's pick really crazy points now. Point, negative 2, 5, and 7, let's do negative 2. All right? We find out the slope. Negative 2 minus 5, and 7 minus negative 2. So just write y minus y and x minus x. That gives our slope. Negative 7 over, that becomes a positive 2, positive 9. So the perpendicular slope, just flip it. 9 over 7 and make it positive. Now the problem is we have to memorize all these rules. And iExcel is there to help you practice, to just give you that fundamental practice to make sure we're all in the same place, in the right place. Now, the last part is this last major SAT type question. I want to spend the rest of our time in class on this SAT type question. And SAT type question says this usually. Given line y equals to, let's say, 2 over 3x plus 6. We're going to say two things. One, write a parallel line passing through point 3 comma -1. So I'm going to draw it up here. I'm going to show you guys that you don't need to draw it. I just want to visually show you what's going on. I give you a graph. 1, 2, 3, 4, 5, 6. We have a slope of 1, 2, 1, 2, 3. And they want us to draw another line parallel, but not crossing through this point up here, but at 1, 2, 3, -1 over here. And they want this to look like that. Oh, sorry, mine's a little off. We want to have the same slope of 1, 2, 1, 2, 3. Okay, that looks a lot better, right? Because I did the lines. Now, how am I supposed to do that? Now, here's the crazy part. We have everything we need already because they gave us a point. The point is 3 comma -1. Now, we just need a slope. Now, do we know what the slope is? If the lines are parallel, don't they have the same slope? So if the slope was 2 over 3 here, my parallel line is also 2 over 3. Now, if you notice what I wrote here, I wrote the point and the slope. Do we have a form for this type of problem? Why, yes, we do. Y minus y1 equals to m. X minus x1. Remember, this is point slope form. So we have a form for it. And you have to learn this form because we're going to use this form all the way to calculus. You think this is it, Mr. Ko, we're going to use it today and we're going to forget it? You'll use this in geometry, algebra 2, pre-calculus, and calculus. So y -1 equals to 2 over 3 x minus 3. I'm going to rewrite this as y plus 1. That's multiply the fraction, 2 over 3 x. 2 over 3 times 3 gives me a -2. Then we write on the side 2 over 3 times -3. The 3's divide out, leave me a 2 times 1, which is -2. Almost done. -1 to both sides. Y is equal to 2 over 3x minus 3. And if we look here, oh my gosh, if I fudge it a little bit, that is -3. If I fudge it a little bit. That's my y-intercept with a slope of 2 over 3. The second type of question that you will see on the SATs and all these standardized tests is they will write 2. Write a perpendicular line passing through, I'm going to say 2 comma 1. So they're going to take exactly the same problem and they say, hey, now I want you to draw a perpendicular line now, except this perpendicular line is going to cross over through 2 comma 1. So the idea is 2 comma 1 versus 1, 2, 3, 4, 5, 6, up 2 over 3. They want me to take this line and try to run into it at a 90-degree angle. How am I supposed to guess what this value up here is going to be? I don't know what this is going to be. So we don't guess. We just use what we know. We know the point that of my new line is 2 comma 1. We know that point. do we know the slope of my new line that's perpendicular to 2x plus 6? What's the perpendicular slope? The flip of 2 over 3 is 3 over 2, and don't forget the negative. This is my perpendicular. Darn it, let me just draw the sign. This is my m perpendicular, my perpendicular slope. So let's go ahead and rock this. Y minus 1 is equal to negative 3 over 2 x minus 2. Careful about those negative signs. And why did I use this form? Because I have a point and a slope. So I'm going to use my point slope form. You could squeeze this into slope-intercept form, and a lot of people teach this and use this. But if you guys are going to Algebra 2, you should learn this form. Now we're going to multiply this out. Y minus 1 is equal to negative 3 over 2x. We're practicing our distributive property. Negative 3 over 2 times negative 2. The 2's divide out, becoming a 1. We're left with negative 3 times negative 1 is positive 3. Almost there. Oops. That's kind of weird. This looks nothing like what I was expecting. Two, 1, yeah. Kind of weird. Why is that? I'm going to add 1 to it, both sides. Oh, I see why. Okay. Is equal to negative 3 over 2x plus 4. Now, my line here was really way off because I'm a terrible grapher. So we're supposed to hit 4. 1, 2, 3, 4. We'll draw this a little nicer. And this was supposed to be perpendicular for us. Change that a little bit. Fudge it a little more. There you go. Yeah, make the lines thicker. Now they look right-ish. So this is our perpendicular line. Negative 3 over 2x plus 4. Now, of course, if I graph this in decimals, it'll be a lot more obvious that these are perpendicular. But the goal here, again, is to be able to use what we've already learned and mix it, right? Do a little fusion, some synergy to it. So these are the SAT type questions that you will see, and this will be on the IXL. They'll give you a starting point, a starting function graph, and they'll say, hey, make it parallel and passing through a point. And we do this. If it's perpendicular, we have a point and we have to come up with our slope. This is that critical thinking, right? This is problem solving. People get paid a lot of money for this. Doctors have to critically think what is wrong. If you come in with pain, they just say, oh, take some Tylenol. No, they ask you a lot of questions to figure out what is wrong. See, I'm asking a lot of questions here, and we have to derive some stuff ourselves. We have to draw some conclusions. And these are skills that we have to learn and grow.